Hey Darryl, what do you got there?
Hey, Colin. Very good question. This is one of our new linear displacement sensors. This one happens to be an HSA-50, which means it has a displacement range of up to 50 millimeters, or basically 2 inches. And this is one of the new designs. We've recently have been working on redesigning the sensor, and there's a couple of nice attributes from this redesign. First off, you're going to find that when you look at the specs for the new linear displacement sensors, that the nonlinearity spec now is back below 0.1%. Over the past few years, you might have noticed that nonlinearity spec had creeped up a little bit, maybe as high as 0.2, 0.3%, and now we're back down below 0.1% or 0.1% nonlinearity. And just to kind of mention a couple of other differences you'll find with the new ones, the measuring ranges are going to be the same. You will find that the color coding on the wire is a little bit different than what we might typically see. And that color coding is the red will represent the positive excitation, and that's pretty typical for our normal nomenclature. Blue represents a negative excitation. Normally for us it's black. This one's going to be blue. Green is going to be a positive signal, and that kind of goes with the way that we normally have our wiring color codes. And then finally yellow is going to be S-. And just like the previous version of these linear displacement sensors, you can take these and you can connect them really to any strain gauge instrumentation, whether it's a P3 strain indicator, or maybe the predecessor to that, a P3500, or maybe you've got a digital data acquisition system like a System 7000 or a System 8000. You can plug these right into those input connectors and plug this right in to a strain gauge channel. These are strain gauge based devices, and there's actually a 350 ohm full bridge strain gauge circuit inside it using the advanced sensors technology. When you look at the output for this particular one is about 9.6 millivolts per volt, so it has an excellent sensitivity. Typically the recommended excitation level for these is around 5 volts. The test results, it looks like, were tested at 5, but you could in general maybe go as high as 10 volts with these. Again, displacement for this one is on the spec sheet is actually 51.24 millimeters, hence the HSA-50. And again, the nonlinearity spec is right at 0.04%. So when you're considering methods of measuring displacement, there's several different products out there. The advantages of using these linear displacement sensors is that they have an infinite amount of resolution. The resolution is really driven by the piece of equipment that you connect to it. Also, when you look at the linearity, like I mentioned before, this one is 0.04%, so that's very, very good. It also takes very little force to displace the end. Typically, it takes less than a pound of force to get the tip of this linear displacement sensor to displace fully. And then when you look at stability and the temperature compensation using strain gauge technology, both of those are very good. So these should last a long time when used in like a laboratory type setting. So again, we've got a new I would say re-engineered version of these. We like to think that they're better. The linearity is better. I think some of the sealing around the ends is a little bit better too, to keep things like dust and dirt out of the internal electronics. And we're looking forward to releasing these new line of linear displacement sensors. And as you may, if you want to find out more information, what I'd recommend that you do is take a look at our website at www.micro-measurements.com. You'll find a product data sheet for these displacement sensors. And one of the things you'll find is that we have 5 different sizes. We have an HS5, an HS10, an HS25, an HS50, and an HS100, again, that corresponds to the amount of displacement. And along with that, you'll find that there are two types of clamps now. We have kind of a single-ended clamp, pretty typical of the clamp that we've had traditionally, with just some minor changes. But we also have a double-ended clamp now. So basically, it's got two loops. One loop to hold the displacement sensor. Another loop is like if you're going to put it around something circular or round. I think it has to be about 1 inch in diameter for that to work. So again, we're pretty excited about these. Tighter specs, a better linearity spec, a new clamp to hold it, and we're looking forward to seeing how these work out in the field.
Sounds good.